We'll proceed in volume in Jacobian, 3D Jacobian in parameterization. Jacobian, that is something we have seen, that is that talks about the interoperability between the different coordinate system as far as integral calculus is concerned. Always say, if anyone you ask in past 100 years how world moved, how world changed, which took the world in its own direction, then I would say electronics. So past 100 years was the era of electronics. I won't say that electronics is place where it won't grow further. It will grow further. But with the carrier, there is a statement called carrier. If I am speaking, it is impossible that someone sitting at 1 kilometer can hear me. Not possible. But people who are sitting across the globe also, they can hear me because there is a electromagnetic radiation carrier is there. So voice is modulated and through carrier, that is high speed, and it goes everywhere. Similarly, electronics can now, whatever the electronics is now, it is at a position and it is sitting at that position for long time. Now, if it wants to move ahead, then it needs a carrier, and that carrier is mathematics. So, on shoulder of mathematics only, the electronics can grow now. So, that is the situation. Now, it is understandable that it may be machine learning, artificial intelligence, whatever, but underneath it is vector, underneath it is multivariable calculus. So we are talking about 3D Jacobian, where we need 3D Jacobian, 2D Jacobian, that is surface Jacobian. If I have integration, if I want to do integration over a region, this is XY plane. If this is XY plane, okay, this is XY plane. If this is XY plane and I have function over X and Y, that is fxy, xy plane and fxy, height, x-axis, y-axis, xy plane, z-axis. Z is not independent. Z is dependent upon xy plane. If there is a different point, if I take on xy plane being x and y both are independent, then there has to be computation based upon x and y as far as parameterization is. Parameterization means a dependent component is dependent upon independent component, and the dependent component's value is computed through independent component as a function, where independent component is passed as a parameter whole. It is called parameterization. Z equal to function over x comma y means this is a kind of parameterization where x and y are parameter to a function f. So z equal to fxy. If I have z, that is the height, and if I have xy plane, so one is height and one is xy plane. If that is the case, then what is the, if this consider this is a surface, if this is a xy plane, this is xy plane, there is a surface. Surface, each point has height z, and each point is mapped on xy plane as x comma y. This point can be said x comma y comma z, x comma y comma fx comma y, x comma y comma fxy. Now, if I have a, okay, so if I have a plane, if I have a xy plane, and if I draw a rectangle here, that is a main concept. If I draw a rectangle here and there is a surface on top of it, and this rectangle is mapped into some area region, if there is a unit change in this rectangle, okay, where this area region, it is mapped over a area region. So there is a region, rectangular region in xy plane. That rectangular region is mapped on surface as area region. If there is a unit change, if there is a unit change that is seen on the rectangle, how many unit change that will be seen in this area? D surface area by dxy plane. D surface area by dxy plane. On the xy plane, if there is one unit of change in the area, how many unit of change that is seen in the surface area? D surface area by dxy plane. If I talk about further parameterization, then if it is xy plane and I am not able to solve through xy, then I go with another plane. This is xy plane, this is another plane called uv plane. Now x and y is dependent upon uv and uv is independent component. They are related to each other through a function. So x equal to gxy and y equal to hxy. If that is the case, then now what about if I draw a rectangle here and this rectangle is mapped on the xy plane to a surface. This xy plane surface, xy plane area is again mapped into z. Z is dependent upon the xy plane. XY plane is dependent upon UV plane. This is parameterization. Now, if I have a rectangle on the UV plane, there is some area on the XY plane correspondingly. If there is one unit of change in XY plane, how many unit of change in area seen in the XY plane? dxy by duv. This is called Jacobian. So dxy, d area in xy plane by duv, where duv I have a rectangular region. If I make one unit of change in uv, how many unit of change is seen in xy? Same way, we had d surface area by dxy. D surface area by dxy, if I have xy plane and there is a surface here and any point on the surface is p, any point on the surface is P, then P is equal to x comma y comma z. dP by dx cross dP by dy. What is P? P vector. P is a point. If I talk about position vector P, then it is x minus 0i plus y minus 0j plus z minus 0k. xi plus yj plus zk or xi plus yj plus fxyk. dP by dx dp by dx, dp by dx gives the vector, velocity vector in xz plane. If this is x-axis, this is y-axis, in xz plane. dp by dy in dyz plane. If I do cross product at each point p, then it gives me dA by dxy. dp by dx cross dp by dy, d surface area by dxy. That is velocity area plane it is called. Every moment, if this is the surface, it is a surface, and if I say dp by dx and dp by dy, then certainly it will be a vector being a cross product. So this vector will here it will have direction like this, here it will have direction like this, here it will have direction like this, here it will have direction like this. So whatever the area at that moment, calculus is not at that moment, it is algebra, it is that moment. Clearly we have described that layer by layer technology grows, where upper layer upper layer adds some new functionality, but for other functionality it is relying upon the lower layer. If calculus is doing something, it is relying upon algebra. So algebra talk about variation as per the xy or fxy, not calculus. Calculus, integral calculus only calculates area. That's it. That's it. Otherwise, every moment infinitesimal small, these are waste statements. That's why calculus could never grow. The way calculus was, it is now also same way. Because There is no layered approach people think. If they talk about calculus, they talk about calculus. They forget that they have to use algebra. If someone is using algebra, then they forget about the numerical science. In mathematics, it is said that 99% of the complexity is handled by numerical science. If you are weak in numerical science, probably mathematics does not belong to you at all. Even though you are very strong in vector and calculus and coordinate transformation and algebra, doesn't make any sense. Similarly, if you see algebra and calculus, then maximum is algebra only. Very small part is calculus. So, like that. So, if I am doing anything in calculus, then I have to be confined myself only to calculation of the area. Whatever the variation as far as variables are concerned, that must be left over the algebra. Each layer will work on its own. So if I have every moment, if I can calculate d area by dxy, d surface area by dxy, and direction would be perpendicular to the surface. So this is similarly, if I have UV plane and if I have xy plane, then if there is a rectangle on UV plane, that rectangle is mapped to some region in xy plane. Rather, I say this is UV plane and this is xy, then rectangle on UV plane is mapped on some region on xy plane. If there is a unit change in this rectangle, brings how many unit change, that is mapped region on the xy plane, that is mapped from rectangle on UV plane, dxy by duv. Okay, that will be dxy by duv. If dxy is a position vector xi plus yj, then dp by du cross dp by dv, dxy by du comma v is dp by du cross dp by dv. This is our fundamental based upon algebra, and this is far easy to understand. Then infinitesimal small you take here and then map to infinitesimal small there, and then imagine this and imagine that, and then vague best book also they talk like this one. Anyway, now scenario is this: if I have an integration over a xy region, if I have a surface function, surface function is mapped on a region in xy plane, but this region can be infinite on the xy plane. Surface is spread over large area, but we are talking about a region in xy plane. Consider, like if I have a sphere, then a sphere has a dimension. Below that dimension, there is a region in xy plane. So if I say surface equation is fxy, then integration in xy plane fxy dxy or dx dy is the volume underneath the sphere. If a sphere is the surface, square root of a square minus x square minus y square, where the region over xy plane is where the sphere maps into the xy plane. But that is not the everything. The sphere maps in the xy plane here, but I don't want this. I want only a small rectangular region around the this center. The blue color is the center. I want a small rectangular region in the center over which wherever it intersects the sphere, for that region only I want the volume, not the full sphere. Then you have to specify the xy plane region. So xy plane region fxy dx dy is the volume calculation in Cartesian coordinate. Sometimes it becomes very difficult and we go for different coordinate system. This is also called parameterization, where x equal to g u and v, u comma v, and y equal to h braces u comma v braces close. So y is function h over u and v, x is function g over u and v. This is delegating the work to another coordinate system u and v because we are not able to find the solution. Typically in a sphere, square root of a square minus x square minus y square. Now x equal to r cos theta means r cos theta means r is v and theta is uv plane. Y equal to r cos theta, then a square root of x square minus a square minus x square minus y square becomes a square minus r square. What about dx dy? Dxy plane can be written as dxy by dr theta into dr theta. Dr theta is dr d theta. Dxy by dr theta, dxy by d theta r becomes x dx by d theta I plus dx by dy by d theta j cross product with dx by dri plus dy by drj. This is called Jacobian. We are now introducing 3D Jacobian. So 3D Jacobian, where 3D fundamentals comes into the picture. We have 3D, like if I have a surface, if I have a xy plane, on xy plane if there is a surface, and if I integrate the surface along the xy plane, the volume what we see underneath coming in the surface, this volume we are calculating, that is 3D, fxy dx dy. What we are talking now, 3D Jacobian. This is 2D Jacobian. dp dxy by duv. This is 2D Jacobian. Surface Jacobian. Volume Jacobian is dxyz by duvw. Where this comes into the picture, people just they remember, they mug up the kind of this fundamentals and they say, I know 3D Jacobian. What is 3D Jacobian? So consider, like I give example of a ball, or let's take, okay, this is really an example. If you see this, it is filled with battery, okay, battery and some electronic circuit, and there is a motor and so many things it is filled with. Now, if I talk about the weight of this, uh, if I talk about weight of this mass, if I talk about weight of this mass, then it has some weight. But if I talk about density, inside it, it is filled. Density of this item, it is variable. Somewhere there is a motor, at that point, the density is high. Okay, if I take it as a solid unit cylinder, then inside it, wherever one motor is there, the density is high. Somewhere there is air, density is low. Somewhere there is a battery of one company, density is high. Other company, density is low. Somewhere there is plastic, so density is low. Like that, everywhere density is different. Or don't talk to me like that. I give me some equation. I'm giving you some equation. The density is fxyz, function over xyz. Okay, now it is all right. Now tell me the function. Give some function. Now that person is substituting x comma y. Now he thinks that this cylinder is centered at the sphere. This cylinder is kept at the origin. Now its base circle is kept on the xy plane and centered at the origin blue color. If it is like that, then this is the height. So this point, if I see, this point is x equal to something, y equal to 0, and z equal to height. If I see other side, then x is 0, y is something, and z is something. Now depend upon the x, y, z as per the function, someone can calculate the density. What is your density function? F, x, y, z. Now, if that is the situation, now I want to calculate the net density. If I have a surface equation and if I can do the integration, it gives me the net volume. If I have a volume equation, if I calculate the integration, it gives me the net weight, because that tag talks about volume density. If you integrate density, then it would give the net weight. Okay, so what is your density? My density is x square y plus 3xyz. Now you take x and y and z, then do x square y plus 3xyz. Whatever comes at that point, that is the density. If that is the case, then over a region, what is the net weight? If I have a surface, if I have a surface like this, then the surface is mapped here over a region. I'm not talking about that region. There is a small region, rectangular region along the center. If that rectangular region is mapped on the surface in some area, that position, if I calculate the volume, how much the volume is, what is the volume of the surface around a rectangular region on xy plane? Then rectangular region on xy plane, function of this fxy dx dy. Like that, I have a density function fxyz. What is the weight of this, what weight of this item over a cubical region? If I have a cubical region, x is from here to here, y is from here to here, z is from here to here. In this particular 3D region, what is the weight? I know the density function. Then over a cubical region, over a 3D region, fxyz dx dy dz. Oh, tell me, I am in hurry. What is your fxyz? Yes, it is x square y plus 3xyz dx dy dz, and then integration over the cubical region. What is your cubical region? I am in hurry. Okay, my cubical region is x equal to y by 2 to y by 2 plus 1. Oh, x equal to the lower limit of x is y by 2 and our limit is y by 2 plus 1. Means x varies as per the y. Mind it, all three are independent now, x, y, z. Okay, what is your y? Y is, okay, this is x. Y is something, okay, 0 to, y is kind of 0 to 1. What is your z? Then z is something like 0 to 1 again. Z is 0 to 1, y is 0 to 1, and x is y by 2 to y by 2 plus 1. X square y, x square y, x square y. I believe I am mixing two different examples. So I will rephrase the limit, but the integrand is same, x square y plus x square y plus 3xyz. Okay, now the kind of z is 0, consider z is 0 to 0 to 1, z is 0 to 1, or z is 0 to 3, okay, z is 0 to 1, z is 0 to 1, x is 1 to 2, z is 0 to 1, x is 1 to 2, and x into y is 0 to 2. I think this is the example we talked in last video. So x is 1 to 2, y x into y, x is 1 to 2, x into y is 0 to 2, z is 0 to 1, x is 1 to 2, x into y is 0 to 2, z is 0 to 1. And now integrand is x square y plus 3xy z dx dy dz. What is your density function? X square y plus 3xyz. Okay, what is the reason over which I don't want to calculate the weight of this full mass over a certain region only? I want the net mass. What is the reason? X is 0 to 1, x into y is 0 to 2, x is 1 to 2, x into y is 0 to 2, and z is 0 to 1. Then density function x square y plus 3xyz dx dy dz dxyz volume, not surface. Now calculate. I don't know, I cannot calculate. It is very difficult. X into y is 0 to 2. How I can do that much? And then it is all right, 2x x square y plus 3xyz, but limit is scary. Then parameterization comes into the picture where the if something is distorted, then we make it straight. We make our work linear. If it is quadratic or it is polynomial x to the power 2, 3, 4, 5, this and that, it is a kind of conversion. If it is a kind that is something made kind of shape, then we make it straight, linear. That's where the parameterization comes into the picture. If limit x is 1 to 2, all right. If z is 0 to 1, all right. But x into y is 0 to 2, x into y, that I have to make it linear. Now, x square y, x into y, x into xy, and then 3xyz, 3 into xyz. Now it is straightforward. How I can make something that is convoluted to straight, okay, that is quadratic or polynomial to monomial or numerical. That is the concept. So xy looks like it is dancing everywhere together. So I can say v equal to x into y and u equal to x and 3z equal to w. Anyway, leave it. Now I'll change this limit to uvw plane. The limit is in xyz cube. We'll change it to uvw cube. And integrand also I will change it to uvw. What about dxyz cube? Dx, dy, dz. How I can change into du, dv, dw? Can I write dx, dy, dz directly into du, dv, dw? Not possible. Because x is not linear relationship with u and y is not a linear relationship with v and z is not a linear relationship with w. Z can be function over u v w. Z, if I do the parameterization, z can contain u v w all three. Y can contain UVW all three. X can contain UVW all three. X equal to G UVW, function G over UVW. This is parameterization. Y equal to H UVW and Z equal to K. I can say G H and F T T U, V, W. So these are the three functions G, H and T that is used as parameterization for X, Y and Z to the another coordinate system U, V, W. Now I had a volume X, Y, Z. Now this volume, on top of this volume, there is a dependent component called the density function. The density is dependent upon xyz. Density is function of f xyz. Now this xyz volume 3D. Now it is dependent upon another 3D, that is uvw. There is a relationship x equal to g uvw, y equal to h uvw, and z equal to t uvw. Since this relationship is through a function convoluted, I cannot say dx, dy, dz, that is the d volume, can be directly converted into du, dv, dw. What I can do? Dx, comma y, comma z, small d in braces, x, comma y, comma z braces close, by d u, comma v, comma w. I'm sorry, dx, dy, dz is nothing but dxyz cube, that is dx comma y comma z cube. So dx comma y comma z is nothing but dxyz by duvw into duvw as per multiplication. Duvw can be written as du, dv, dw. This is what we wanted. But extra thing came as dxyz by duvw. This is called Jacobian, three-dimensional Jacobian. Now I can change everything. Limit from xyz cube to uvw, xyz cubical region to uvw cubical region. Integrand xyz to uvw cube, but and dx, dy, dz to du, dv, dw with one Jacobian, that is dxyz by duvw. If that is the case, then how I can calculate this Jacobian. Now that consider I have what I did earlier. If I have xy plane, on top of it there is a surface, and surface, any point on the surface is P, that is x comma y comma z, z being height or fxy, then P equal to xi plus yj plus zk dp by dx. dp by dx cross dp by dy. Only these two are independent. That is nothing but on this surface, any point P, I have dA by dxy. dp by dx cross dp by dy is dA by dxy, and it results, cross product results in an area vector. This is the area vector. This here area vector is like this. Here area vector is like perpendicular. Every moment dp by dx cross dp by dy is different. D surface area by dxy plane is different. What about if instead of this xy surface, I have xyz cubical region, and on top in this cubical region, I have any density function. Consider density function is something imaginary. Density in this cubical region, everywhere density is different. So any density I take point P, then P density function any point P, that is x comma y comma z, that is the independent component, comma d, that is density. So x comma y comma z comma d. So dp by dx cross dp by dy cross dp by dz. Okay, can I do like that? dp by dx cross dp by dy cross dp by dz to get the volume vector. I did dp by dx cross dp by dy to get the surface area vector. That is d surface area by dxy. What about d volume by dxyz? Can I do dp by dx cross dp by dy cross dp by dz? Mind it, even though x, y, z are independent to each other, but they are orthogonal to each other. So if this is x-axis, this is y-axis, independent to each other. This is xy plane. Z is perpendicular to the xy plane, but it is also independent. But it is perpendicular. So if I do cross dp by dx and dp cross dp by dy, since dp by this is nothing but d surface area by dxy plane, their area vector is going along z direction. If I do cross product again, then it will be 0. So it is called triple scalar product. If I want to calculate d volume by dxyz, then dp by dx cross dp by dy dot with dp by dz. This is called triple scalar product. This is how we calculate the volume vector. Okay, dp by volume vector, in the sense there is no volume vector. The dv. So d volume by dxyz is nothing but dp by dx cross dp by dy, whatever the surface area we are getting, dot product with dp by dz. Now we have dx comma y comma z. We said dx comma y comma z is nothing but dx comma y comma z by duvw into duvw. duvw numerator is du, dv, dw. Now here dxyz by duvw. Now we have uvxyz volume, and there is a density function. If I calculate d density density by dxyz, then it is, if there is a point there, then dp by dx cross dp by dy dot dp by dz. In similar fashion, if density is a function over the xyz volume, if density is a function over xyz value, and then if I am trying to calculate d volume by dxyz, if there is a unit change in xyz volume, not area, volume, how many unit change that is seen in the kind of in the kind of if this volume is mapped, okay, this volume is mapped on the density cube, then how much density cube volume is changed. Similarly, I think it will be more clear now. Similarly, it is similar to I have xyz cube. Xyz cube is there where xyz are independent, and there is another cube I am taking uvw. Now xyz is dependent upon uvw. Okay, these are two coordinate system now, xyz and uvw. Now if there is a cube I take in uvw plane cube, this cube would be mapped into some 3D region in xyz. 3D, it may not be cube as per the function. If there is a unit change in this cube, if there is unit change in this cube, then how many unit change the 3D shape that it is mapping from cube to 3D shape in XYZ, how many unit change I can see in this 3D. If there is a cubical region in UVW plane, this cubical region is mapped into XY in UVW coordinate. If there is a cubical region, that cubical region is mapped into XYZ coordinate system as some 3D shape, may not be cube. If there is a single unit change in this cube, meter cube, then how many unit of change it is seen in this 3D? D XYZ by D UVW. Okay, if I have a xyz as the cube, this cube is mapped to some density function. If there is a unit change in this cube in xyz coordinate, there is a cube. If there is a unit change in the cube, then how many unit change I see, that is the mapped cube in the density area, that is dp by dx. If I take any position vector there, position vector in the density area, that is xi, that is p. P is xi plus yj plus zk plus density something, force coordinate. So dp by dx will come as I xi plus d density by dx, some force coordinate, dp by dy j plus d density by dy, some force coordinate, dp by dz, that is k, and d density by dz, force coordinate. Now if I do dp by dx cross dp by dy and then dot product with dp by dz, it gives me the volume change, the 3D volume change in density region by 3D volume change in the XYZ region. Similarly, if I have UVW coordinate system and XYZ coordinate system, there is a cube in UVW. There is a cube in UVW. That cube, how much one unit change brings the 3D shape that is mapping to XYZ coordinate system, then dXYZ by d UVW. If in xyz any point is xi plus yj plus zk, that is the kind of the vector we are talking, then that vector by du cross that vector by dv, dot product with that vector with d dw. Okay, so dp by du cross dp by dv and all together dot with dot product with dp by dw. It resolves in a kind of a matrix where the top is dx by dui plus d. So if I see this, then what is dp by dx? dp by du, dx by dui plus dy by duj plus dz by duk, one vector, cross with dx by dvi plus dy by dvj plus dz by dvk. Calculate the area vector, cross product area vector, and then do dot, because it will be in k direction. Now do with dot product with another one. So if you do this, it will resolve in a matrix that will be, if you settle it down, it will be dx by du in a first row, dx by du, dx by, Actually, it will be dx by du, dy by du, dz by du. Next row is dx by dv, dy by dv, dy by dz by dv. Like that, third row, dx by dw and then dz by dw. You can rearrange and it becomes dx by du, dx by dv, dx by dw, dy by du, dy by dv, dy by dw, dz by du, dz by dv, dz by dw. If you calculate the determinant, you get the solution, or anyway you know it, it is nothing but dp by dx, dp by du cross dp by dy, whatever you get dot product with dp by dz. Same thing would come as per the matrix fundamental. I'm really sweating badly. Okay. So, okay. So we will see that example with this fundamental of the 3D Jacobian. This is sweating in 3D only. What will happen in artificial machine learning where dimensions are 100, 1000, something like that. Here in three dimensional, this is the situation. So the technology will grow now in arena of the way it is happening in the arena on top of on carrier of mathematics only, and it is getting difficult day by day. But what can be done? So we will talk more on it, and we will solve the our integration, that is x square y plus 3xyz dx dy dz, where dx dy dz will transform into dxyz by duvw du dv dw. So this Jacobian we will see more. We will see.